Hey, so let's look at this packet of 6 questions meant to help you get ready for the Math SBA this year. Because these are really important, they're review, and because they're designed to help us do better on the SBA, I'm going to talk about every single question because I want you to have some way to check to see if what you're doing with each question is right. I may or may not actually get to the answer for each question, but I'll at least tell you how it was supposed to be done, set it up, so at least you know you're on the right track. Or maybe I will get the final answer for all or whatever. I don't know. We'll see. So the first one says, Elijah bought 3 3/4 pounds of ground hamburger meat for $11. Enter the price per pound. So I see this right here. I see price per pound. And remember, we used to talk about this all the time at the beginning of the year. Per, when you're in a math class, 99% of the time can be replaced with the words divided by, and then it's almost like a set of instructions telling you how to do the question. If they want their answer in price per pound, or as the way we would say it is price divided by pounds, well, then that's really all you have to do. The price, $11 here, divided by the number of pounds, 3 3/4, and you're going to get your price per pound. So let's do that. Let's do the price, which is $11. But since I'm kind of working with fractions here, I'm going to write it as 11 over 1. And then I want to divide that by the 3 3/4 pounds. But I don't like doing math with mixed numbers. So what I'm going to do is I'm going to turn this into an improper fraction. And I do that by seeing that 4 times 3 is 12. Or in other words, 3 is equivalent to 12/4. And then I already have this additional 3 up here in the numerator. So this is the same as 11 divided by 1 divided by 15/4. And then we do fraction division with what we call a keep change flip, but more technically it's called multiplying by the multiplicative inverse. But we say keep change flip. So I'm going to keep 11 divided by 1. I'm going to change to multiplication. And then I'm going to flip 15/4 to 4/15. And what we get is 11/15. And so what that means, this is in dollars, because this is in dollars per pound, right? So that's what they asked for the question, for the answer in. But they want us to round to the nearest cent. And I don't think 11/15 really qualifies for that. And so I think we need to do 11 divided by 15 to see if we can get this in, cents. But I don't know on the SBA if this is the type of question where you'll have a calculator available to you. Some questions on the SBA, the screen provides you with a calculator to use, and some don't. So let's talk about how you would do this if you didn't have a calculator and all you had was scratch paper. Well, the number that's on the top of your numerator, that is on the top or is in your numerator, if you're going to try to long divide by hand, that's the one that goes in the box, as we say. So in class, I'll always just remind you to say box top to yourself. And so the 15 is going to go on the outside. And so we want to see how many times 15 can go into 11, but it can't. So we just put a 0 there. We're going to add a decimal. If we add a decimal in here, we got to immediately add it there. And now I can extend this number out with as many zeros as I want. It doesn't change it. It's still 11. And so now instead of thinking about how many times does 15 go into 11, I'm thinking about how many times does 15 go into 110. And I don't know, I just start counting up by 15s. Let's see here, 6 times 15 would be 90. So one more 15 would get me to 105. So that's probably right. So it's going to be 7 here. So now I multiply back. 7 times 15 is 105. And I subtract down, so 110 minus 105, that's a 5 here. All right, so you should kind of know how to do this algorithm from here, so I'm going to let you finish it. But your answer should be obviously 70-something cents. You got to get whatever this next number is, and you got to get whatever that third number is to see whether or not you need to round up or round down. All right, so let's move on to number 2, though. Let's see here. Let me see if I can adjust this a little bit so that maybe you can see. Okay. It says Jacob and Isaac decided to run to the basketball court after school. The basketball court is 5 1/4 miles from school. The boys run at a pace of 3 3/8 miles per hour. Enter the length of time in hours it will take to get for the boys to arrive at the basketball court? And your answer should be a mixed number. Okay, so if they're running 3 3/8 miles per hour, well, and they got to go 5 1/4 mile, then they're definitely not going to get there in 1 hour. So let me think, would they get there in 2 hours? Well, if I multiply 3 3/8 by 2, I get 6 6/8. That's more than 5 1/4. So it's going to take them longer than an hour, but not quite 2 hours. So whatever math I do here better get me an answer between 1 and 2, or else I know I messed up. Well, I feel like they expect you to know this equation here. If you know how fast something is going, let's say it's speed. Sometimes people use R for rate, but I'm going to use S for speed. And you know how long something is traveling at that speed, so this is time. Then if you do speed times, this is a multiplication dot, times time, that equals distance. In other words, like let's say you were going 60 miles per hour for 2 hours, well then that means you traveled 120 miles per hour. All right, so speed times time equals distance. Well, how does that help us here? They gave us a distance and they gave us a speed. So if we fill in the gaps with what we know from the question, then 3 3/8, I'm putting that where the S was because that's a speed. And then I still have T for time because they didn't give me a time, but they gave me a distance, 5 1/4. So 3 3/8 times whatever time is supposed to equal 5 1/4. And I know using our Module 3 algebra skills that I could divide both sides of this equation by 3 3/8. And I would get the time. So time is going to equal whatever 5 1/4 divided by 3 3/8 is. And I don't like to do math with mixed numbers, so I'm going to turn both of these into improper fractions. So it's going to be T equals 4 times 5 is 20 plus the additional 1 up here, that's 21/4, divided by, well, 8 times 3 is 24 plus this additional 3 up here, that's 27/8. All right, so I think I'm going to let you finish this one from here. You got to keep change flip this fraction division here to get your improper fraction answer, and then you need to do some simplification and turn that improper fraction into a mixed number as the question is asking for. All right, so I'll let you take it from there. Question 3. It says select 2 tables that represent a proportional relationship between x and y. So remember, proportional relationships are all about this equation. Y equals k times x. This is like a big deal for the first 2 or 3 months of the school year. And this k right here, we called the constant of proportionality. And so what's special about these types of relationships is whatever the y value is, like on the bottom of these tables, you have to be able to get to that y value by taking its associated x value, so the x value that's right above it, and multiplying it by this same number k throughout the entire relationship. So if this times 2 equals this, then like this top number times 2 has to equal the bottom number, and then the next top number times 2 has to equal the bottom number. It has to be constant throughout. The relationship has to remain constant in that way. And so that's what we're looking for. We're looking for 2 relationships where if you multiply the x value on top by the same number each time, you always get the y value that's directly below. And so I look at A and I see 0 times whatever is 0, so that works. Remember, we always have to have 0 in these things. But then I see a 3 and a 9, and I know 3 times 3 is 9. So the only way this can remain proportional is if the top number times 3 equals the bottom number every time. If it's any other number, it doesn't work. And so I see a 4 on top here times 3 would be 12, but I have 16 down here. And so this is no longer proportional. There's no constant of proportionality. So I'm not choosing A. I look at B and I see we got 0, 0, so that's good. 1 and 4. So 1 times 4 is 4. 3 times 4 is 12. 5 times 4 is 20. Each top value times 4 equals its associated bottom value. I would agree that this is a proportional relationship. All right, let's see here. Let's move on to C. 2 times 7 would get me 14. 6 times 7 would get me 42, and 10 times 7 would get me 70. So this is a proportional relationship as well, too. So this one would be a proportional relationship with k equals 4, and this is a proportional relationship with k equals 7. So I don't even need to check that last one because they said there was going to be 2 to select. All right, let's look at number 4. It says, the graph below shows the amount of money earned based on the number of hours spent tutoring. And I know that this is a proportional relationship right off the bat because it goes through the origin, it has 0, 0 in it, just like we expect to see 0, 0 in these tables. And then it's a straight line. And remember, those were the 2 things that we looked for in a graph to see if it is representing a proportional relationship. It's got to go through the origin, and it's got to be a straight line. So let's see here. I want to select true or false for each of these statements, these 3 statements here. So I'll just write a T or an F next to them. It says point C represents the total amount earned after 4 hours. Well, let's see here. 4 hours spent tutoring, they made $60. That's not point C. Point C is after 3 hours. So I'm going to say false. Next, it says the total amount earned is $6 after tutoring for 90 hours. So I'm down here, I'm looking at the x-axis, and it says hours spent, and I see a 6. And then on the y-axis, I see dollars earned at 90. So it's 6 hours equals $90. And they're trying to mix you up and say it's $6 after 90 hours. Nobody would do that work. All right. And the last one says the total amount earned is $15 for tutoring for 1 hour. So I go on my x-axis where it says hours tutoring, 1 hour, I move up, I see $15. Yep, that one sounds right to me. All right, moving on. It says, number 5, Jessica went shopping and bought a pair of jeans that were on sale for 25% off the original price. So this feels more like the percent questions we're doing in class right now, more so than a proportional relationship review. But I haven't really talked about it so much in class, but percents sort of act just like a proportional relationship. The way you figure them out and the way that the operations work, they're so closely related that you could basically say that percents are a proportional relationship. So I could see why they would put this in this category. Anyways, it says Jessica went shopping and bought a pair of jeans that were on sale for 25% off the original price of $23.98. And so that's going to be hard because they're giving you $23.98 instead of just like a flat $24 to work with. All right, a 6% tax was also added onto the sales price. So you got to reduce $23.98 by 25%. And when you do that, that'll get you some number. Let's say you put the number in the box there. Oops, I'm off the screen. And then you want to take that number, whatever that number is, and increase by 6%. And whatever you get there will be the final answer. So, and I'd like to think that if they were asking you to do 25% of $23.98, that would be a question you'd get a calculator for in the SBA. But let's talk about how you would do it if you didn't have a calculator. The first thing I think about is the fact that 25% is equal to 1/4. And so we need 1/4 of 23.98. If we could figure out what that is, then we just subtract it off of 23.98 and we'll be fine. Well, to find 1/4 of a number, we're just going to divide it by 4. So we need to do the long division 23.98 divided by 4, which could be kind of tough, but I'm also thinking about the fact that this is so close to 24, and let's see here. Yeah, 6 times 4 is 24. So this should be like ever so slightly underneath 6, right? Probably like 5.99, maybe point something. So let's look. How many times does 4 go into 2? 0, obviously. How many times does 4 go into 23? 5 whole times. And then you multiply back, 5 times 4, you get 20. We're going to subtract down and get this 3. And then I have a decimal point here, so I'm going to make sure to write that decimal point up here. And then I bring this 9 down. And see, we have 39, which 4 can go into 9 whole times and almost 10 times, right? This is almost 40. So we put a 9 up here. 9 times 4 is 36. And we subtract down and we get a 3, and we bring this 8 down, and see we're still almost at like another 10, because 4 can go into 38 9 whole times, and then that 9 times 4 is 36 again, and we subtract down again and we get 2, and now we need to bring down another 0, we get 20, and 4 can go into that 5 times. We get $5.99, and then this 5 out here, so it's like half of a cent. And it says round your answer to the nearest cent if necessary. So I guess maybe we're supposed to just round this up to $6 even, because this 5 pushes this 9 to a 10, so you have to carry that over, and that pushes this 9 up to a 10, which is really just a 0, and that pushes this 5 up to a 6. So maybe it was just, the whole thing was just a trick to see whether or not we could figure out how to round that. But really, we're going to say that 25% of $23.98 is just $6. Like if you round to the nearest cent, that's what you get. So we're going to reduce $23.98 by 25%, which is $6. So $23.98 minus 6 is what you should have in this box here, and that's $17.98. And now you're going to increase that number by 6%. And since we've been working on this so much lately, I'm going to assume that you know how to do that. So I'm going to leave the last part up to you. You need to take $17.98 and add a 6% tax to that. All right, and the last one we're going to do, it says Jeremiah paid $29.52 for a pair of boots that were on sale, and the original price of the boots was $36. So enter the percentage discount for the cost of the boots. So first let's figure out like how much was the discount, not in terms of percent, but just in terms of like the dollars off. So 36 minus 29.52, well, $6 from 29.52 would get me to 35.52, and then I just need another 48 cents. So it's a $6.48 discount. And so if we just represent $6.48 as a percent of 36, that tells us the percent discount. And you can always find what one number is as a percent of another by just dividing them, right? If you do this division, 648 divided by 36, you get what percent 648 is out of 36. Another tough division though, I don't know if you're gonna get calculators for this on the SBA, so you would need to put that top number in the box, 648, and divide it by 36. And since 36 doesn't go into 6, I'm going to put a 0 there. I'm going to put my decimal, and I'm going to think about how many times 36 goes into 64, which is only one time. So this is going to be, well, I see a 0.1. There's going to be some other number here. So this is going to be something like a, yeah, maybe, well, it's going to be more than a 10% discount, because I think about a 10% discount off of 36, that would be $3.60. We're way over $3.60. So this is going to be somewhere around like an 18% discount, 17% discount, somewhere around there. So if you finish this long division, you get something like 0.17, 0.18, and then you move that decimal over a couple spaces, you probably got the right answer. So I'm going to let you finish it. I encourage you to try practicing some of these long divisions and doing some of these calculations by hand. I know it's tempting if you have a calculator at home to just grab the calculator, but I don't know what you're going to have available to you on the SBA, so just be ready.